Log on, tune in, find out. Another good idea from Cambridge.
Also at the Catholic University of Leuven as a doctoral student, and she will be talking about improving the efficiency of individualized designs for the mixed logit model by including covariate information.
Okay, so good afternoon, everybody. As was introduced, my presentation will be about... Can you speak up a little, please? Yes, I'll try. So as was introduced, my presentation will be about improving the efficiency of designs for the mixed logit choice model by using covariate information of the respondents in the survey. And this is joint work with my supervisor, Martina van der Broek. This is the outline of my talk, so I will start with a very brief introduction about what we mean with covariates and why it could be beneficial to incorporate that information in the analysis of your choice data. Then I will discuss or explain how you can incorporate covariate information in the analysis of the mixed logit choice model, but then also in the setup of the choice sets for this model. And at the end, I will discuss the simulation study that we did, where we incorporate all these ideas. So recently in the discrete choice literature, there has been a huge interest in covariates. So more and more researchers are convinced that not only the attributes that describe the profiles in the choice sets influence the choice behavior of the respondents, but also covariates can say a little bit more about the preference structure in the population. So covariates are, for example, demographics like the age and the gender of the respondents, but also some sociographic information. Covariates can be any respondent characteristic that is related to the choice behavior of the individuals. So we will take this information into account when setting up the choice sets for the mixed logit choice model, and also in the analysis or in the estimation of the model. So as is clear from the title, we use the mixed logit or random effects discrete choice model to analyze the choice data, as this is a more realistic approach in analyzing choice data, as for example the conditional logit model, where you only have one aggregate set of model parameters. Now, what is done already in the literature is incorporating covariate information in the estimation of the mixed logit model, more specifically in the hierarchical Bayes estimation of this model. But we extend previous work by not only including this information in the estimation, but also in the experimental design of the model. And we wonder whether we can improve the accuracy of the individual level estimates, of the individual level parameters of the mixed logit choice model by taking this covariate information into account in both design and estimation. So the mixed logit choice model is a hierarchical two-level model, where at the lower level you have the choice behavior of the respondents, which is modeled with the conditional logit model, and then you have an upper population level where we account for the preference heterogeneity in the population. So as I mentioned before, instead of considering one aggregate set of model parameters, we assume an individual specific parameter vector beta n for each individual separately. And we take this vector constant over all choice sets, and as such we account for correlation between subsequent choices. Now, as this vector is taken constant over all choice sets, you can model the individual choice behavior with the conditional logit model, and as such you can use the well-known conditional logit formula for the probability that an individual chooses an alternative k in choice set n. And then at the bottom of the slide you see the likelihood function of a series of choices for S choice sets, for example, for a specific individual. Now, maybe I will go to the next slide first. So in the mixed logit choice model, you have this individual parameter vector, beta n, and then we consider a heterogeneity distribution over these individual parameters. Now, when you don't take covariates into account, you just get an aggregate mean mu, but we will take covariates into account in the mixed logit model, and more specifically in the mean of the heterogeneity distribution. So where does this distribution come from? We assume that the individual parameters beta n, I'm sorry, I have some issues with my lens. So we assume that the individual parameters beta n depend on covariates according to this regression model. So you have the covariates in the vector Zn for each individual specifically, and then you have the regression parameters, the theta matrix, that expresses the sensitivity of the individual parameters with respect to the covariates. Then there's also an error term for which in most cases a multivariate normal distribution is assumed, and as such we get a multivariate normal distribution for the individual specific model parameters, but now not with an aggregate mean mu, but with an individual specific mean that depends on the covariates. Now, when we integrate this likelihood conditional on the individual parameters, when we integrate this out over the heterogeneity distribution, you get the unconditional likelihood for a respondent's set of choices. Now, as was explained before, with this integral it gets a lot more complicated to construct designs, to construct optimal designs for this model. So here we also consider the individualized design approach. And what is new here is that we also incorporate the covariate information in this individualized design approach. I will go very quickly over the steps in this approach, as it was already explained in the previous presentation. I will just highlight where the covariate information comes in. So there are two steps in this approach, an initial step and then a sequential step where the choice sets are added sequentially. So in this initial stage, we construct a specific individual design, more specifically a semi-Bayesian D-efficient design for each individual separately with, for example, S1 choice sets. But we constructed a semi-Bayesian D-efficient design, so we need a prior distribution to integrate the D-error over. And for this, we assumed this multivariate normal distribution. So as we believe covariate information matters, we also incorporate this covariate information in this prior distribution, which comes in with the vector Z. Now, there's also the hyperparameters from the population, which we need prior values for, and in most cases this comes from a pilot study or from some previous experiments. Then once we've obtained the initial experiment for each individual separately, we can observe the corresponding responses, the corresponding choices, and that choice information is then used to update the prior information we already had. So it's just with a Bayesian rule, by multiplying prior with likelihood, you get an updated version, so you get a posterior distribution for your individual parameters. Now, this updated prior information is then used to construct the subsequent choice set. So for that, we consider all possible candidate sets, and then we minimize the expectation of the D-error over the combined design, so the design we already had, and then the additional choice set that comes in. And we minimize the D-error over this updated prior distribution, so the posterior distribution that we've obtained. So as such, an additional choice set is constructed. We again observe a choice, and that new choice data is then used to construct the new choice set and so on. So in the individualized design approach, you have a recurring process of updating your prior information and then using with the observed choices, and then using that new information to construct the new choice set. And it goes on until you have a specific amount of choice sets. To see whether the incorporation of covariates in both design and estimation of the mixed logit choice model was beneficial, we set up a simulation study, and so we wanted to verify whether we get more accurate estimates for the parameters at the individual level in a mixed logit choice model. For that, we considered 4 different design and estimation combinations, which are described in this table here. And they are defined by whether or not the covariate information is used in the design stage or in the estimation stage. So first have a look at the design stage. We either constructed individual designs, so a design for each person separately, where we either included the covariate information or did not include that information. And as a sort of benchmark, we also considered a design and estimation approach where we used an aggregate design in the design stage, which was a nearly orthogonal design, so the same design for all respondents. And then same story for the estimation stage. We estimated the mixed logit choice model with hierarchical Bayes estimation, either incorporating the covariates in the heterogeneity distribution or not. I gave a specific name to these four approaches. So of course the C stands for the fact that we use the covariates, the NC that we do not use the covariates in either design on the left hand side or estimation on the right hand side. Now the third and the fourth approach do not make use of the covariate information, so that's indicated by NC and C. But then the difference between those both approaches is that the NC-NCI approach, there we construct individualized designs, whether the O stands for the orthogonal design, so the aggregate design that we use. All designs that we constructed consisted of 16 choice sets with 16 choice sets with 3 alternatives, yes. And the alternatives are specified or described by 3 attributes with 3 levels each. We coded the attribute levels with effects coding, and as you will see in the results, as such we get a dimension 6 for our model parameters, for our vectors of model parameters. And then for the individualized design, we constructed 5 choice sets in the initial stage of the design approach, and then sequentially added the 11 remaining choice sets. We considered a specific setup for our simulation study. More specifically, we considered 4 specific scenarios defined on assumptions made on either the pilot study and on the true choice behavior of the population. Now, for the pilot study, in each setup, we assumed that there are 250 individuals in the study. Now, as I explained here, to construct the initial choice sets for each individual separately, we already need some prior values for these population parameters here, the theta 0 and the sigma 0. And for that, we assume that the estimates for those prior values come from a pilot study. Now, for that pilot study, we have 2 scenarios. So we either assume that all 250 respondents from the main study are also used in this pilot study. So in total there are only 250 respondents. The other case is that we consider 100 additional respondents, so different respondents from the ones that are in the main study. So in this second scenario for the pilot study, there are 350 respondents in total. Then for the true choice behavior, we assume that it's either influenced by covariates or not. We considered this B scenario, so the case where the true choice behavior is not influenced by the covariates, to verify what the effect is on the estimation accuracy when we use covariate information that in reality is actually not of use. So that does not influence the choice behavior. In the paper we had 2 parts, one part with 1 binary covariate, the other with 2 binary covariates, but here I will only discuss the 1 covariate case, as the results from the 2 covariate case are similar. To compare the different design and estimation approaches, we considered some performance measures. So we computed a root mean squared estimation and prediction error, as is defined here and here. So for each individual, we simulated a true vector of model parameters, which is the beta star, and then with each design and estimation approach, we estimated those parameters, and then they are compared in this estimation error. Now for the root mean squared prediction error, we considered the design with all possible choice sets with 3 alternatives. Now remember that the alternatives were described by 3 attributes with 3 levels each. So you have 27 possible products, possible profiles. And from those 27 products, you can construct 2,925 choice sets with 3 alternatives. So this design, including all those possible choice sets with 3 alternatives, has in total 2,925 times 3 profiles. And for all those product profiles, we constructed or we computed, calculated the choice probability with either the true parameters for the individual and then with the estimates. And then in an equivalent way, we constructed this root mean squared prediction error. Now, besides these mean errors, we also computed the errors for each individual specifically, and then we also had to look at the percentage of respondents for which an approach yields the smallest estimation or prediction error. Now, as for the results, so I will go over the 4 scenarios. Remember that the first scenario assumed that there are 250 respondents both in the main study and in the pilot study. So the same respondents are used in the main study and in the pilot study. And secondly, we assume here that the true choice behavior is affected by 1 binary covariate, which takes on the values -1 or 1. So as choice behavior is affected by the binary covariate, we simulated the true model parameters from this multivariate normal distribution, where here you can see the values that we assumed in the study. So this binary covariate divides the population in 2 subpopulations, 2 segments with different mean choice behavior. Now here are the results, here are the performance measures. Now it's quite clear that the CC approach, which incorporates the covariate information both in design and estimation of the mixed logit model, is clearly, well, the best approach. It outperforms the 3 remaining approaches for all performance measures. Here is just a graphical representation of the results. So we've plotted the individual errors, so on the left-hand side the individual estimation errors, and on the right-hand side the prediction errors. The CC approach corresponds to the black curve, and as the black curve is the leftmost curve in both plots, this is again an indication that the CC approach is the best approach here. So that it's interesting to incorporate the covariate information when indeed it affects the choice behavior of the respondents. The second scenario, same assumption about the pilot study, but now the true choice behavior is not affected by the binary covariate. So we do not observe segments, we just assume a single heterogeneous normal population. So we do not have the covariates in the mean, we just have a single mean vector mu star, and here are the values that we considered. Now remarkably, the CC approach is still the best approach. The difference with, for example, the NCNCI approach, where we do exactly the same thing, so construct individual designs and estimate a model with hierarchical base but without using the covariates, the difference between those 2 values, so for the CC and for the NCNCI, is smaller than what we saw in scenario 1, but still for all performance measures, the CC approach is the best approach. This is quite remarkable because we use information that is actually superfluous. But the reason for this is probably because we have quite a large pilot study. Moreover, we use the same individuals in the pilot study as in the main study, and that's probably well, too good to be true. In reality, that's not the case, I think. So that is why we considered a 3rd and a 4th scenario. Yeah, that's again a graphical representation of the results. So we considered the 3rd and a 4th scenario in which we consider a smaller pilot study and moreover different respondents in the pilot study than in the main study. Now for the 3rd scenario, again the true choice behavior is affected by the binary covariate, and here we see that it's beneficial to incorporate or to use the covariate information. Now it's the NCC approach, so the approach that only uses the covariates in the estimation and not in the design, that has the smallest mean estimation error, but as you see, the difference between those 2 is neglectable. Okay, and then finally for the fourth scenario, where the true choice behavior is not affected by the covariate, here we see that now the NCNCI approach, so not using the covariate information, corresponds to the smallest estimation error. That's not a surprise, as the covariate information doesn't influence the choice behavior, so you should get quite accurate estimates without using that information. Still remark that for the other performance measures, the CC approach is still the best approach here. So in conclusion, this research shows that the use of covariate information in design and estimation of the mixed logit model can be quite valuable. So especially when it influences the choice behavior, it's very beneficial to include it in the setup of your choice sets and in the hierarchical base estimation of the model. We also saw that even when the covariates, or the two covariates, do not influence the choice behavior, it was still, well, not harmful to include that information, as the CC approach was either still the best approach, or as you could see here, the decrease in estimation accuracy is actually neglectable. It's not the lowest value, but it's not much higher than the value from the NCNCI approach. Now, you should be careful with the last conclusion, because I did an additional simulation study where I considered 10 covariates that were superfluous. So choice behavior was not influenced by the covariate values, but I did include that information in design and estimation. And then I observed a huge decrease in estimation and prediction accuracy. So you should not just include covariates irrationally, you should think well about it. And I think the advice should be to consider just a few well-taught covariates from which you're truly convinced that they influence the choice behavior. And when even afterwards you found out that it does not influence the choice behavior, you see from this fourth scenario here that it's not all that harmful. So, although this is only a simulation study, it shows, I think, that covariate information can be very valuable in the analysis of choice data.
Wow, so you picked the wrong strategy. Now we have 10 minutes. Are there questions for Marjolein? Well, I'll start with one just to warm things up. Your difference in the covariate, the one binary covariate, was a huge change in utility, one that's not often seen in choice experiments, even for the primary attributes, let alone the covariates. What was your rationale for that big change between, 0.5 to 1.5 in that one study?
You mean the choice of the
effect of that covariate? Yes, you can see theta is changing in a huge way, going from one to the other, right? Value for the covariate.
I believe I don't fully get the question.
You see the difference between 0.5 and 1.5 in the utility assigned to the different covariates, right?
Oh, perhaps I didn't explain this very well. This column concerns the covariate, and this is just intercept.
Oh, okay.
So sorry, I didn't explain this very well.
Yes.
250 individuals participate in both the pilot and the main, but in the main, are there more individuals?
No, just the 250. So we construct individualized designs for these 250 respondents, or we just, in the fourth scenario, we all give them the same design. But to come up with prior estimates for the population parameters, we consider a pilot study. And in the first and the second scenario, we use the same 250 respondents to come up with those prior estimates. So in total, there are only 250 respondents in that setup. But as we believe that is probably not that realistic, such a large pilot study and moreover using the same respondents, we considered also a third and a fourth scenario in which we use 100 additional respondents. So there in total, we have 350 respondents. Which is probably also not quite realistic, because from previous presentations I heard that a pilot study with 100 respondents is even quite large. So we should do some additional research and lowering the information from the pilot study, maybe even set up some experiments with no pilot study at all, to see what the effect is on the accuracy of the estimates. Probably it will, we will get not that nice results, but we'll see.
Just in follow-up to his question, I've not seen the distinction between the pilot study and the main study already. So it seems like you have the same number of people in the same study. So what's clearly the difference between the two?
So, here. So, in the design stage, we either construct an individual design for each person separately, or we use the aggregate orthogonal design. And in this design stage, we do this for 250 respondents. And then with choice data from these 250 respondents, we estimate the mixed logit model with hierarchical base. But to come up with estimates for these population parameters, so the theta 0 and the sigma 0, we consider a pilot study. And in this pilot study, we either use those same 250 respondents, or we use 100 additional respondents. Is that more clear?
So if you use the same people in the pilot study and in the main study, do those people give the same answers, or are they now suffering from fatigue?
No, in the pilot study we gave them an orthogonal design, just an aggregate design.
So
Because at that
it was
point,
different,
yes.
different questions, okay.
In practice, would you also use a pilot study to decide which covariates are worth including in the real study?
Yeah, we didn't consider this here. We just assumed the covariates, but indeed, that's a good point.
This is an excellent point. What I see happening very much in practice is that people who design these surveys ask a huge number of demographic questions of every respondent, and then so you would be overwhelmed by the amount of covariate information that you have if you were trying to use it in the design. So there's very little hope of being able to use that kind of sort of core dump in the design phase. So this kind of work could help kind of people pare down their sets of demographic variables. But I think the idea that Steve just had is great.
That's the comment I gave at the end. So you should not put covariates in irrationally, but I hadn't think of the idea to use the pilot study to actually decide on the covariates. That's a very good point.
I think we're out of time. Thank the speakers.